All right, gentlemen. Welcome to our live streaming session. This next section in the packet has to do with particle motion. And we did particle motion first period with just regular looking functions. In this case, what we're doing is we're taking trigonometric functions and looking at them, which conceptually shouldn't be any harder, but it just looks kind of weird. So I'm trying to get to that pen here. Oh, my pens aren't opening up. There we go, finally. Okay, here we go. Took me that time to get a pen. Okay. So we have this problem, particle motion with trigonometry, and we have this scenario for t between 0 and 12 seconds. A particle moves along the x-axis. The velocity of the particle is given by this function v of t equals sine of pi over x t, and the particle's position x equals 3 at time equals 0. And so what conceptually this means is that you have time, and as time goes, it starts out at x equals 3, there's a particle. As time goes between 0 and 12 seconds, this particle will move along this x-axis. And it first asks the question for A, for t is between 0 and 12 seconds, one's particle moving to the right, justify your answer. Well, you might remember back again from first semester that to look at this, if you have a between 0 and 12 seconds for t, let's say this is t in our number line, and we have v, this is going to be v of t, which is the same, it's going to be x, so position, we'll call it x of t. So v of t is going to decide if the particle is moving left or right between t equals 0 and t equals 12. And so we already have this v of t is already a derivative. Our inclination would be to take a derivative of this, but we're already given velocity, so all we need to do is evaluate this function here. So we have v of t equals sine of pi over 6 times t, and it's the sine of this whole thing, pi over 6 times t. And so we have to evaluate the sine of pi over 6t, positive or negative, because that's going to determine which way this particle is moving along this x-axis. Okay, so what we have is, if we take a unit circle, that here's a unit circle, our sine is going to be positive whenever we're up above the x-axis. So we have between 0 and pi, when we're in this interval between 0 and pi, and sine is positive, well, sine is positive here. So if we plug in t, well, if t is 1, for instance, for t equals 1, then we have sine of pi over 6. And sine of pi over 6 is positive. Okay, where does sine start to go negative? Well, sine starts to go negative at, if you think about it, at pi, right? And so if t is 5, we're still positive, but for t equals 6, then we have sine 6 pi over 6 times 6. So we have sine of pi, and that is equal to 0. So we know at pi we have is one of our critical numbers. And then if we go all the way around back to 2 pi up here, okay, that's also going to be 0. Now we go up to 12, and a total rotation is 2 pi, which is 6.28. And then if we go around again, the circle a half more time, we can go to 3 pi, where the sign is 0. And then we don't get around to 4 pi because that's going to be 6.28 times 2, which is going to be something like 12.5 something. So this is the entirety of our interval. So we know between 0 and pi, sine is positive. So particle moving up, which means moving to the right. And between pi and 2 pi, negative. Between 2 pi and 3 pi, positive. And between 3 pi and 12, negative. And so now we can say, to justify, we would say because v of t is greater than 0. That's our justification. And where do we see that happen? So we say particle moves right on, we have these intervals here between 0 to pi, and also I have a union here between 2 pi and 3 pi. Oops, 2 pi, 3 pi. And here's our justification, okay, because v of t is greater than 0. Okay, write an integral expression for the displacement of the particle. Now, do you remember the song that we sang? It said, in AB calculus, in order to be great, don't hesitate to eliminate the rate, okay? So to find distance, we need to eliminate this rate. And so to eliminate the rate, we need to integrate. So if we integrate v of t dt, that's how we're going to get distance or displacement. Okay, so to put down specifically what this is, the integral expression is going to be here between t equals 0 and t equals 12. So 0 to 12. And by the way, we're going to be able to use our calculator for this too in a couple parts here. So we have sine of pi over 6 times t dt. So that will be our answer to part B. Okay, to C, write an integral expression for the total distance of the particle between 0 and 12, and use the calculator for that. Now here we're going to have this particle moving left and right. We know we're starting at 3, but we are moving initially in a positive direction until t equals pi, and then moving in a negative direction, then in a positive direction, then in a negative direction. So in total distance, we have to account for each of these various movements. It's like if you were walking in a straight line and then walking back and forward and backward and forward, and you know the total distance you covered, which is given by this integral expression. But to get the total distance covered, we have to account for each of those going forward and backward. And so what this is going to be is, our answer is going to be between t equals 0 and pi, sine of pi over 6 t dt. Okay, and the next piece is we're going in a negative direction. So we can do this a couple of different ways. One we could do is we could subtract this next piece, but instead what I'd rather do is this. I'd rather take an absolute value bracket and put absolute value of between pi and 2 pi of sine pi over 6t dt. Okay, and then plus, okay, we got another interval which is going to be between 2 pi, because this interval we're going in a positive direction, between 2 pi to 3 pi. We have sine pi over 6 t dt. And then here we go, here's our last piece here, absolute value brackets. We have sine, I forgot to make the integral symbol. That's going to be between 3 pi and 12. Absolute value sine pi over 6 t dt. Okay, let's go to the calculator. And here I am for pre-calculus. I need to change this back to radian views and a regular function. Here's radian. There's my radian thing, and I'm going to change this back to a regular function. So we are in radians. So let's go look at this. We have the integral. Let's see, it's math. Oops. Yeah, it's second somehow. I didn't want that. Let's try this second. Man, I'm just messing this up. Okay, math. Okay, 9. I didn't want it in there. Let's quit. Math 9. We go between 0 and pi. Okay, second pi. We have sine. We have pi over 6. X dx plus, to get absolute value brackets, there are different ways. One thing you can do is you can go to second catalog and just press enter, and that gives you your absolute value bracket. So we're going to go between, we go to math 9, we go between pi and 2 pi. We go sine pi over 6 x dx. Okay, we go to the right of this here, plus, now we're going to go between 2 pi and 3 pi times sine pi over 6 x dx plus, we get our last absolute value bracket here, catalog, enter. So we go to math 9, we're going to go from 3 pi to 12, and it's going to be sine pi over 6 x dx. Okay, when I press enter, what is the first thing I'm going to be thinking about? I'm just hoping to heck I have a positive number, for one thing. So I press and think. So 2.977. So equals approximately 2.977. And what I would hope is that there's some intuition behind what that number is. And I don't see a whole lot of it right there. My guess is that if we went all the way to 2 pi, maybe that number would be pi. But so that would be our total distance covered there. Next, D, find the acceleration of particle at time t. Is the speed of the particle increasing, decreasing, or neither at t equals 4? Well, acceleration, okay, of t equals v prime of t. So it's going to be this sine, the derivative of this. And so what is the derivative of sine? It's going to be cosine. So that's going to be cosine of pi over 6 t times, using the chain rule, the derivative of the inside, which is going to be pi over 6. Right? Because that's the derivative of the inside of this. So for this, we're interested at where t equals 4. Well, v prime, which is a of 4, is going to be equal to pi over 6 times cosine of t equals 4, so 4 pi over 6, which is going to be 2 pi over 3. And going back up to our unit circle, what is going to be cosine of 2 pi over 3? Well, it's going to be negative 1/2. It'll be right up here at 2 pi over 3. So sine, or cosine, will be negative 1/2. So we get negative 1/2 times pi over 6 which is going to be negative pi over 12. Okay, and then it's asking the question, is the speed increasing, decreasing, or neither at t equals 4? Well, let's go, what do we need for increasing, decreasing? We've got to look at if the velocity is positive or negative, and if the acceleration is positive or negative. So where is 4 located? Right here between pi and 2 pi. And so velocity is negative and acceleration is negative. So since, the way we'd write this, since v of 4 and acceleration of 4 are both negative. Are negative. What do we conclude? We conclude speed is increasing. Okay, so now we go to the next page, which is part E. Using a calculator, find the position of the particle at t equals 4. Well, we already know that at 0, at t equals 0, we have x equals 3. So position is equal to 3 plus the integral from 0, t equals 0 to 4, sine of pi over 6 t dt. And for that, we can go to our calculator, and here it is. Okay, we have 3 plus okay, we go to math 9. We go from 0 to 4. Oh, I don't know what happened there. Where do we get this 10? I don't get that. It said 0, 10. So 0 to 4. Okay, we get sine pi over 6. Okay, pi over 6. X dx. One common mistake on a problem like this is people forget to put the starting position in place, which in our case is 3. So we press that. So our position is going to be 5.865. See if that'll make 5.865. Okay, really, so that's all I intended to go over today. What I want you to do for class this week is look at problem 2, which is this one right here, particle motion with trigonometry, and it's like the last, it's similar to the last problem, except it's a different equation, and you're given position to start out with, and so to find velocity, you'll need to find v of t is going to be equal to the first derivative of this, which is going to be x prime of t. So take that first derivative of this, and then you'll have the velocity and acceleration, and then it'll give these parts C and D. So work on that one, and I think that's it. I think it's just parts A through D, if I'm not mistaken. Yeah. So that'll be it. So anyway, I'm going to close out here very shortly. Do you have anybody have any questions before I sign off? I'll just hold it here. I had both Robert and Ryan chime in last time. This time I try to be more careful about what's going on there. Okay, well then that'll be it. And I will talk to you later.